All right, the next assignment on the list is assignment number 16, properties of exponents, and it looks like this. You'll also notice if you ever were to try to take notes at home, like I have copies of all these worksheets up here, but if you lose your copy, then you can print this out. And the place that you can go to print it out is the home page. So this is the paper version of where you're taking the notes. All right, so if you need to print that out to get another copy, it's right there. And assignment number 16 is going to cover the properties of exponents in a way that I really like. So I did just write the test and the final, and you are going to find these types of questions, that is, questions where you have to find the mistake. So there's going to be 2 or 3 of those on the test. And this one, all right, so this one is a little bit weird because it doesn't actually start off by using one of the properties. It uses a distribute step. So this is actually legal. If I took this expression, 15 over 5 to the negative second power, that is if I took this thing right here. All right, what if I were to take that and distribute? So is this legal? So I'm going to give the exponent on the outside to both the negative 15, or rather both to the 15, why did I put 12, and to the 5. And let's look. Is it true to say that 15 to the negative 2 divided by 5 to the negative 2, this, is equal to this? Yes, it is. So this is a legal step, and the reason why is because of the distributive property, if you like calling it that. You could also say because you're multiplying, so you distribute this negative 2 both to here and to here. So yes, this is legal, check mark, by the distributive property, which is rule 3. Okay, and then what changed between these two expressions? So I'm going to write the two things on top of each other, and then I can look at to see what changed, and then decide if what changed was good or was legal. So let's see. I'm going to write this expression on top, and then underneath it I'm going to write what I got, and then I'm going to look for what changed. So what stayed the same first of all? The negative 2 stayed the same. Okay, so what changed was the 15 over 5. And that turned into 3. Well, is it legal for 15 over 5 to turn into 3? Yes, that is legal. Okay, so there's no mistake there. They just turned 15 over 5 into 3. And it's kind of backwards. If you've just been memorizing the rules, you know, when to multiply, when to subtract, then you're going to be really confused by that. This assignment really requires a much deeper understanding of the rules of exponents. So yes, that's legal. And then 3 to the negative 2 by the negative power rule. The negative power rule was the 1 over rule. So it's perfectly legal to put 3 to the second on the bottom here. In fact, you probably should. Okay, and so that's legal as well by rule 4, or the negative power rule. Okay, and so the answer for this one is that there was no mistake. This one, even though the type of question is different, so this isn't a what's the mistake, it's a select all that apply, it still is using the same distributive rule. Okay, so just like here, I started by turning the 15 to the negative, I just undistributed. I'm going to take the same step here because they're both get the negative 3, they both have an exponent of negative 3. So this is the same as putting a parenthesis around the 20 over 4 because they both got the 3. So the 4 would get the 3 and the 20 would get the 3. So what I did in the first step was get 20 over 4. And then just like in the previous problem, the next step was to say that what's in the parenthesis, 15 over 5, could be simplified. So what's in the parenthesis here, 20 over 4, can be simplified. So that's 5 to the negative third. Okay, so that is what I'm looking for. And now I'm going to look for all the different things that mean the same thing. So here are some of the things that mean the same as 5 to the negative third. 5 to the negative third is the same as 1 over 5 to the third, and that is the same as 1 over 5 to the third, and that is the same as 1 over 5 times 1 over 5 times 1 over 5. These all mean you're dividing by 5 3 times. So the count of 5s is 3, and it's 1 divided by 5. So divide by 5, divide by 5, divide by 5, divide by 5 3 times, or divide by 5 3 times. All right, so I know that this one was correct because this was what I was looking for exactly. And then the thing that's also equal to that, well, this one is also equal to that. And what you'll notice that actually if you make out this list of all the things that 5 to the negative third is equal to, then you're going to be most of the time you're going to catch one of the select alls. And I should give you a warning every time that it's time to pause, so it's time to pause right now if you're still doing that one. So let's do the next one. Again, 1 over 4 3 times, so I'm dividing by 4 3 times, is the same as 1 over 4 3 times is the same as 1 over 4 to the third is the same as 4 to the negative third. So any of these are what I'm looking for. And this one is correct. And then sometimes you have to actually apply the rules of exponents in order to figure it out. So I have 1 over 4 once, and then I have 1 over 4 2 more times. So that makes a total of 1 over 4 3 times. In other words, just 1 plus 2 is 3. And so this is also on my list of possibilities. Yes, I am dividing by 4 3 times here. Once and 2 more makes a total of 3. Pause here. And here is another example of that weird distributive property. And I can tell because both of these things have the same exponents instead of the same base. So just like these had the same exponent and I could distribute, or these two, 15 and 5, had the same exponent so I could distribute or undistribute. It's actually the opposite of distributing is called factoring, but we haven't quite done that yet. So in any event, this is 4 times 4 and 2 both being raised to the third power. So 4 to the third and 2 to the third. And then I'm going to actually, I had a student the other day suggest that I use brackets out here so that I can put the 5 out on the outside so that I'm not using parentheses all the time. And then now, just like in the first two, so then I turn 15 over 5 into 3, or I turn 20 over 4 into 5, or in this case I can turn 4 times 2 into 8. So my expression is going to be 8 to the third to the fifth. And then by the distributive rule, multiply the inside exponent by the outside exponent, I get 8 to the 15th. So I'm looking for any of these, and let's see what I get. 8 to the 6th to the 5th, no, I wanted 8 to the 3rd to the 5th, so this one is not right. Okay, and then the next one, 8 to the 15, yes, that one works, and so my answer is 8 to the 15, and pause here. Okay, let's write all the things that are equivalent to 1 over 9 3 times. Give me just 1 second, TJ. Okay, so that is the same as 1 over 9 3 times, and that's the same as 1 over 9 3 times, and that's 9 to the negative third. Okay, so I'm looking for 9 to the negative third, what I'm looking for. And this one is obviously not correct because it's 9 to the 5 minus 2, which is 9 to the positive third. So this is 9 to the positive third, and I was looking for 9 to the negative third, so this is not right. But a lot of people are picking this distractor because they've forgotten that the negative in the exponent means take the reciprocal. Okay, so the negative in the exponent turns 1 over 9 into 9 over 1 to the third, and so this is, again, 9 to the positive third. So these two are both the same. They're both 9 to the positive third, but I wasn't looking for 9 to the positive third, I was looking for 9 to the negative third. Let me slow down and do that one again. So another way of writing this would be 1 over 9 to the negative third, and then when it goes up into the numerator it becomes positive, 9 to the positive third. All right, so these two were 9 to the positive third, and I wasn't looking for that. So the answer is none of the above. Please pause here. Which expressions are equivalent to this thing? This thing is 7 to the 1, 2, 3, 4, 5th power. So that is what I'm looking for. Now, let's see if any of these give me what I want. This one is 7 to the 8 minus 3, which is 7 to the 5th. And then this one is 7 to the 5 plus 1, which is 7 to the 6th. So I wanted 7 to the 5th, and the one that is this. Pause here. Neil tried to simplify the expression step by step. So in step 1, Neil took the top, -6, and the bottom, -4. And in between there is what the operation was that he used, and he subtracted. He subtracted. And we need to decide if he should have subtracted or not. Subtracted. Good. Subtracted the two exponents. Should he have done that? Yes, because the rule for dividing two powers is to subtract. This is fine. And now let's check our subtraction. -6 minus -4 is a keep, change, change. So keep this, flip that, change this. and there's 2 extra negatives in the 6, so that's -2. So the exponent should be -2. Is it -2? Yes, it is. So everything is fine there by the keep change, I guess, if you want to call it that. And then the negative power rule is the 1/over rule. Is it legal to put 5 to the -2 on the denominator? Yes, it is, and so there is no mistake. And pause here. Eric was now simplifying this other expression step by step. So he took the exponent on top, which was 2, and the exponent on bottom, which was -5. And in between there is the operation that he did, which was he did what? He added. And now we need to evaluate, should he have added? And the answer to that is no. When you're dividing 2 powers like that, he should have subtracted, but he should have subtracted the exponents. It should have been 2 minus -5 instead of 2 plus -5. So step 1 was the mistake. All right, and that is assignment number 16. When you do this assignment, you should find it a lot easier now because a lot of the questions are actually exactly the same as your notes. So make sure that you don't put these notes away. You will find these exact questions both on the test and on the assignment.